Welcome back, everybody. This is Mr. Paredes, and today we are going to be going over Unit 1, Lesson 2, Recognize Proportional Relationships in Tables. Okay, and this begins on page 11 of our Into Math workbook. All right, so let's look at page 11, Spark Your Learning. For which tables can you predict the cost of 100 units of the item? Explain why you can make that prediction for some of the tables and not for the others. For the tables that let you predict the cost of 100 units, find the cost. Okay, so let's look at the peanut butter here, the first table. I have 8 ounces for $3, then 16 ounces for $4, 40 ounces for $6. If I look at my increases here, I increased by 8, and then I increased by 24. Okay, now let's look at the right side. This was an increase of 1, and then from 4 to 6, it's an increase of 2. So just based on this, when I increased $1, it was for 8 ounces. But the very first row shows 8 ounces for $3. So when we add just 8 more ounces, when it doubled in size, it was just $1 more. And the same thing almost with from 16 to 40, it was an increase of 24 ounces for $2, which means if I divide that, 12 ounces per dollar. So the constant or the unit rate is changing, so it's not constant. So there's no way I can predict for 100 units or 100 ounces because the price keeps changing for every ounce. So let's look at our binder clips. 12 binder clips for $2. If I divide it 12 by 2, that would give me 6, which means it's 6 binder clips per dollar. However, if I look at this row here, if that was the case for $5, I should get 30 binder clips because 5 times 6. However, it's for $5, it's 36 clips. And when I look at the price of $6, it's for 50 clips, which is almost 9 clips a dollar, right? Because 54 clips would make it 9 per dollar. So this one is the same as the peanut butter. We don't have a constant rate, right? So this one doesn't work. There's no way I could figure out how much 100 binder clips would cost because the price per clip is getting smaller for the more you get. All right, so let's look at the trail mix. For 2 pounds, it's $6, right? For 8 pounds, $24, and for 12 pounds, $36. So let's look at our increases here. When this increased, it was plus 6. This one increased plus 18. Okay, this one increased by 12, and this one increased by 4. All right, now obviously we have different increases and such, but if I divided them out, 18 divided by 6 would give me 3. If I went 12 divided by 4, that would give me 3. So this looks like it has the same unit rate every time. If I looked at it from just 2 to 6, if I divided 6 by 2, I would get 3. Same thing with 8 and 24. 8 times 3 equals 24. 12 times 3 equals 36. Right? So this has a constant rate. So technically for this one, I can figure out how much it is for 100 of them, right? I could predict that. I know 1 pound, if I had 1 pound, it would be $3 based on this rate. So for 100 pounds, 100 times 3, I'm looking at $300 for 100 pounds of trail mix, right? All right, so let's look at the shower sponges. 4 shower sponges is $8. For 8 of them, we're looking at $16, and for 10, we're looking at $20. Now, if we look at our rates or how much they increase, right? Just looking at the tables, this is an increase of 4. From 8 to 10, we're looking at an increase of 2. Okay. On the right side, I have an increase from 8 to 16. That's an increase of 8. From 16 to 20, that's an increase of 4. So I have a rate of 4 shower sponges for $8 and then 2 for $4, right? And if you notice, from 4 to 8 in the shower sponges, that's 4. And from 8 to 10, that's 2. That's half. Well, the cost is the same thing. It was $8, and then for half the amount, it was half of $8, right? $4. So, looking at these, if I divide it for $8, if I divide it by 4, I'm going to get 2, right? So that means 4 times 2 would give me 8. Would that be the same for 8 and 16? Yeah, 8 times 2 equals 16. So if it's a constant rate, that means 10 times 2 should equal that cost of $20. So this one has a constant rate, right? So we would be able to predict this one for 100 units. Okay, so for 100 sponges, if we went the cost for just one sponge, we're looking at $2 for one sponge, right? So for 100 of them, we're looking at $200. All right, so let's look at page 12, Build Understanding, Task 1. Maxine walks dogs to earn extra money. The table of values shows the proportional relationship between the number of dogs Maxine walks and the amount of money she earns. So we have our dogs walked and the amount she earns in dollars. Part A, show that the ratio of dogs walked to amount earned is a constant ratio. All right, so I have dogs walked over amount earned, or the money, right? Which is 2/7. That's our first rate they gave us. Now let's look and see if 4/14 is equal to this. What number can go into both 4 and 14 evenly? 2 can, right? 4 divided by 2 is 2. 14 divided by 2 is 7. This one works. What about 6/21? Well, 3 can go into both 6 and 21. 3 goes into 6 2 times, and 3 goes into 21 7 times. So this one has a constant rate, and we can prove it by showing simplest terms, right? For part B, it says show the ratio of amount earned to dogs walked is a constant ratio. So now it's basically the reciprocal, right? I have my money, the amount earned, over dogs walked, which would be 7/2. So if I flip these, 14/4, again, I'm using the same numbers. 2 goes into both of these, and it would be 7/2, right? If I had 21/6, I can use 3 again, and that would give me 7/2. So this is how I prove that it's a constant ratio, even the reciprocal of it, right? So I know based on this table, these are all equal to each other. It's a constant rate. For part C, what is the unit rate of dogs walked per dollar earned? Right? And does it make sense? Well, we know it's 2/7, right? That's the ratio. So for every 2/7 of a dog, you're going to get $1. Does that make sense? Of course not. No, it doesn't, because you can't walk a fraction of a dog, right? It's not possible. So yes, that's the rate, 2/7, 2/7 of a dog per dollar, but that's not a good use of it, right? Because it doesn't make sense. All right, so continuing on with part D. What is the unit rate of dollars earned per dog walked? Does it make sense? So we're looking at basically what we did in part B. We have our rate of 7/2, right? $7/2 per dog walked, right? Does this make sense? Or can it make sense? Well, $7/2 is the same as saying, and I'm going to put or, it's the same as saying $3.50 per dog, right? So does that make sense? Yes, it does make sense, right? Because we can use fractions for money because we can represent it as a decimal, just like we did here. For 7/2, it's the same as $3.50, right? 7/2 of a dollar. So we can represent it as that. Now for part E, it says, what is the constant of proportionality, K, in this situation? So we want to know what K is. Well, the constant of proportionality is the unit rate. And our unit rate could be money per dog, right? And in this case, it could be 7/2 or 3.5, right? So that's your constant of proportionality for this. So for part F, describe what the unit rate K represents in this situation. Well, it represents how much money Maxine makes or earns per dog walked, right? So that's what your constant of proportionality, or K, represents. It's the unit rate. So what is she getting? And in this case, we're looking at dollars per dog walked. So K, 7/2 or 3.5, represents how much she makes per each dog that she walks. All right, so let's look at page 13. Task 2. Two relationships are represented in the tables. Which table shows a proportional relationship and which does not? Explain. So in this case, we want to find the unit rate or the constant of proportionality, right? So we want to know what K is. Now K is always Y over X. Okay, that's our constant of proportionality. So in table 1, remember, I want Y over X, right? So K equals Y over X, which equals, the first one would be 36/3, right? Well, what's 36 divided by 3? That would be 12. Okay, now I want to use the second one to see if it's the same. 72 divided by 6, or over 6. That would also be 12. Okay, so far so good. Now we have to see if this one matches up. I have 84 on the top, right? And 7 on the bottom, because it's Y over X. 84 divided by 7 would also give me 12. Okay, so looking at the bottom part, the ratios y over x are equivalent. Therefore, the relationship shown in this table is proportional. Okay, it does have a proportional relationship for each one. They are all equal to each other. All right, now let's look at table 2. So I'm going to do the same thing. I have 48 over 4. Well, 48 over 4 is 12. Okay, now let's look at the next one, 55 over 5. Well, 55 divided by 5 is 11, so it's not 12. And 64 over 8 would be 8. So no, this one doesn't have a constant rate. So the ratios y over x are not equivalent. Therefore, the relationship shown in this table is not proportional. Okay, so remember, we're looking for k. Okay, your constant of proportionality. That's going to tell you if it's a constant unit rate, right, or constant rate, if the unit rates are constant. So this is one way that you can solve that, right? Taking y over x for each table and making sure they're all equivalent. All right, so let's jump ahead to page 14, task 4. The equation y equals 12x represents the number of inches y in x feet. Now, if you remember, y equals kx, where k is the constant of proportionality, right? And in this case, this is almost the exact same thing. Instead of k, we have 12. So that means 12 is my constant of proportionality. So for part A, the equation y equals 12x does represent a proportional relationship. And it asks, if so, what is the constant of proportionality? And how do you know? Well, the constant of proportionality, k, equals 12, right? Because we're pulling it straight from that equation. Y equals kx, and in this case, y equals 12x. So k equals 12, and that's our constant of proportionality. For every one that it's going to increase, we're going to use a constant rate of 12, right? It'll always increase by 12. So let's look at part B. Use the equation to complete the table of values for the relationship between inches and feet. So I know for 0 feet, I'm going to have 0 inches, right? Because I'm using this equation, y equals 12x. Every single one of these values right here for the x, I'm going to plug in. So for this one, it would be y equals 12 times 0, which is 0. So I'm plugging in each one of these numbers for x to find out what the y value is going to be. So 1 times 12 is 12. 2 times 12 would give me 24. 5 times 12 would give me 60. Now, to figure out what my x values are for these, right, I would go the opposite. What times 12 is going to give me 36? Well, 12 can go into 36 3 times. And 12 can go into 48 4 times, right? So that's how I can find out those missing ones. Now, if you didn't want to multiply or divide, you could have simply looked at the table. We're increasing by 1 each time right here, right? And on the bottom, we increased by 12. Well, if we do that again here by 12, then I have to increase by 1 again up here, right? So you can always figure out your missing ones the same way. So the reason I know it increases 12 on the bottom for every 1 on the top was because of K, right? I know K was 12 or is 12, which K is the same as Y over X. So for every increase of 12, it's always an increase of 1 on the bottom, right? Or in this case, it's the reciprocal, but it's always Y over X, okay? All right, guys, so that's it for the lesson 2 video. I hope it was helpful for you. Make sure you subscribe to the channel if you haven't already, so that way every time I post a new video, you automatically get that notification. Make sure you have your book if you haven't picked it up yet. And also make sure you're turning in your work, right? There's no point in doing all this stuff if you're not going to turn it in and get your grades for it. Okay, so make sure you stay on top of all the work. Make sure you're following along. If you have any questions, reach out to me, dojo, email, and set up tutoring. Okay, so I hope you guys are doing well. I hope you had a great weekend, and I look forward to seeing you in class. Those of you who are online, my Packet Kids, I look forward to getting your work. And as always, you guys, take care.